Okay, this is me trying for the third time this video. As you can see, I've already done a bunch of this stuff and the phone cut off and erased the video. Okay, 5.4, evaluating trig ratios for angles between 0 and 360. So I mentioned in 5.3 that before, when you learned in grade 10, we're doing angles from 0 to 90. Now we're looking at angles from 0 to 360. Okay, so we did a kind of a diagram with this in 5.3. Okay, so we said that this arm here is called our initial arm. And then if we rotate a arm from here upward clockwise, this becomes our terminal arm. Okay, initial being the beginning, terminal being the end. And then what we could do is create a triangle between the initial arm and the terminal arm. Okay, so we could create a triangle. So before we were learning, when we do SOHCAHTOA, we were learning that we do the H, the O, and the A. So the hypotenuse, the opposite side, and the adjacent. But now we're switching, since we're on a Cartesian plane, we are changing the values to X. This is our X value, our Y value, and this arm here is our R, which is our radius. Okay, and then the angle that is in between the initial arm and the terminal arm is our principal angle. And then the symbol for it is theta. Okay, so theta is always between the initial arm and the terminal arm. In 5.3, I introduced the related acute angle. And the related acute angle is between the terminal arm and the x-axis. Okay, so we'll look at the related acute angle, but only in quadrants 2, 3, and 4. Okay, so again, our hypotenuse is now our radius, our adjacent side is now x, and our opposite side is now y. But for me, I still use O, H, and A when doing the ratios, but you could use the X, Y, and R. Okay, so that's what it's talking about here. So the opposite side is Y, adjacent side is X, and then our R is the hypotenuse. Okay, if we usually know the X and Y based on a point, but we usually don't know what the radius is. So determine the radius, we use Pythagorean theorem. But instead of C, A, and B, we use R equals X squared plus Y squared, all of it square rooted. So the same thing as B squared plus C squared, and then square root the last step. Okay, you guys could read the other stuff here. Okay, so now if we move over to a second quadrant, so this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So now we move the terminal arm over to the second quadrant. So we still have our initial arm here along the x-axis, and then from the initial arm to the terminal arm is our principal angle, which is theta. But now we can't make the triangle over here because that would be an obtuse triangle. So our triangle now goes from the point down to the x-axis and across. The angle that is in between this angle, or in this triangle now, is called our related acute angle, or beta. So this is our related acute angle. Oops. Sorry, you can't read that really well. Related acute angle is beta, and our principal angle is theta. Okay, so we still have our x, y, and r. In this case, the x value would be negative, but don't worry about that right now. Okay, so we have our y value, and our r is always, our radius is always positive. So that says something over here. R is always positive. Okay, so now our trig ratios. So we had sine, cos, and tan. So we used to have the O over H, now it becomes Y over R. Our cos, which is ka, so SOHCAHTOA, was A over H, but now it's X over R. And tan, which was O over A, is now Y over X. But again, you can still use the O, A, and H. Okay. Okay, then we're looking at our reciprocal functions. So cosecant is the reciprocal of sine. So it's just a reverse. So it used to be H over O. Now we have secant, which is the reciprocal of cos, which was h over a, and cotangent, which is the reciprocal of tan, which used to be a over o. Okay, but we never use the reciprocal functions. We always switch back. We always switch back to the primary trig ratios. Okay, so now we have something called the cast rule. So the one question for homework in 5.3 was to help you create what's called the cast rule. So you're supposed to do the little chart of positive and negatives. So what I want you to do is, what I wanted you to do was to plug a value into, a value between 0 and 90 into your calculator for sine, cos, and tan. So if you did sine 45, cos 45, and tan 45, you notice that all your answers were positive. Okay, if you did it from the second quadrant, so you pick a number between 90 and 180, so say you plugged it 100 degrees. So if you did sine 100, cos 100, and tan 100, you'll notice that your sine value was positive. Okay, now we continue. So if you did a value between 180 and 270, so say 200, so you do sine 200, cos 200, and tan 200, you notice that only tan was positive. And then lastly, in this quadrant, again, a number between 270 and 360, plug it in, and you'll notice that only cos is positive in this quadrant. Okay, so going back, if sine is positive here, that means cos and tan are negative. If tan is positive here, sine and cos are negative. And if cos is positive here, that means the other two, sine and tan, are negative. So this creates what we call the cast rule. So C is positive, so C, A, S, T. So cast is the acronym. So cos is positive, but you have to, it's just a quick way to remember. So we start in the fourth quadrant. So C, first quadrant A, second quadrant S, third quadrant T. So C cos, A is all, S is sine, and T is tan. So that is the cast rule. Okay, so the point 512, example 1, 512 is on the terminal arm of an angle, theta, in standard position. State the primary trig ratios. Whenever it says primary trig ratios, they want to know what are the values, or what are the signs for sine, cos, and tan. Okay, so if we draw the point 5 and 12, it's up here. So on my x-axis, I just labeled it 1 through 5, and then I didn't have enough room, so I went up by 2's here. So I have 5 units along the x-axis. So this is our x value. 12 units on the y-axis. So 12 is y. Okay, and then ignore this 13 because I just solved it, and I'll show you what we did. So we have 5 for x and 12 is y. This r was not given. Okay, so this is your x value. This is your y value. So we have to find the r value. So in order to find the r value, we do the formula that was on the first page. Okay, so we use this formula here. So our x was 5, so 5 squared. Our y is 12, 12 squared. So 5 squared is 25, 12 squared is 144. Add them together, you get 169. And when you square root 169, you get 13. Okay, so that's where the 13 comes in place here. So our radius is 13. Okay, then we want to find our trig ratios. So sine is y over r, so 12 over 13. Our cos is x over r, so 5 over 13, which is here. And tan is y over x, so 12 over 5, which we have here. Okay, and then the second part of the question asks you to find theta. So theta is the angle. So we're finding theta. So you could take any one of these and you could find the angle. Okay, so I'm just going to use the first one. So we want to find what theta is. So anytime we're looking for an angle, remember you have to do something on your calculator, and that is the inverse function. So we isolate for theta by bringing the sign over, okay, or cancel it out, and it becomes sine inverse of 12 over 13. Okay, so that's what I did here. So we have sine inverse of 12 over 13. So just to show you on my calculator, okay, so shift or second function, sine, will give you the inverse function. And then we have, what is it, 12 over 13. So brackets 12 divided by 13, close the bracket, and you get the answer of 67 rounded. It doesn't tell you what to round to, so let's do the whole number. So 67 degrees. Okay, if you do any of the other twos, you'll get the same answer. So just to show you, if I did cos now, so shift cos, and bracket, what do we have for cos? 5 divided by 13, close bracket, get the answer of 67 once again. Okay, so it doesn't matter which one you use, you'll get the same answer for the angle. Okay, so that was the first example. Okay, second example now. So point -4, 3 on the terminal arm. Okay, same things, find the trig ratios and theta. Okay, so I drew it here. So when we draw, so we have the initial arm, and now -4 and 3 is right here. So -4 and 3. So we have -4 on the x values, but we could just leave it as +4. And we have 3 up on our y-axis. So we have our x and our y. So again, we want to find the radius. So I did that here. So you can plug in -4 here. It doesn't matter because you square it. And when you square it, it becomes positive. So you could use a negative or positive value here. So 4 squared, which is our x, our y value is 3, so 3 squared, so you get 16 plus 9, which is 25. You square root it, and you get 5 units. So our radius is 5. Okay, but key note here, so we have the triangle here. So the angle we're able to find is in this part here, and that's no longer the principal angle. The principal angle is between the initial arm and the terminal arm. So what we have here is our beta. Okay, so we could find beta in this case. So beta is in between the terminal arm and the x-axis. Okay, so when we set up our trig ratios, it's sine beta, cos beta, and tan beta. Okay, so this one is y over r, so 3 over 5. Cos is x over r, so 4 over 5. And just lose the positive values, it's fine. And tan is y over x, so 3 over 4. And again, so we want to find, the question actually asks us to find theta, but we can't find it right now. We have to find beta first, and then we'll find theta. So we'll do inverse. So again, I'll do sine. So sine inverse of 3 over 5, and you get the answer of 37 degrees. Okay, so our beta is 37 degrees, but the question asks us to find theta, which is our principal angle. Okay, so what I showed you in 5.3, that from the terminal arm, from the x-axis to the next x-axis, so we go all the way around, that's 180 degrees. Okay, and we just found that this angle here was 37. So if I want to find the principal angle, I take 180, subtract 37, and that will give me what remains. So theta is 180 degrees, subtract 37 degrees, which gives you 143 degrees. Okay, so this first one was beta, and then that is theta. Okay, now example 3. Find angle A to the nearest tenth of a degree if A is between 0 and 360. Okay, so this is going to relate to what I did in 5.3. Okay, so let's find A by doing inverse first. Sine inverse 0.3214. So angle A, so let's do it. Shift sine of 0.3214, close bracket. I get 18.7 degrees. Does it say nearest tenth of a degree? So I'm going to round to 18.7 degrees. Okay, so here we'll get actually two answers. Just let me double check the textbook to see what it wants. Just give me 1 second. Just want to confirm something. Okay. So going back to our cast rule, sine. So this is sine we're doing, and so we have a positive answer. So what happens is we actually get two answers. We always get two answers. You get one that's going to belong into the first quadrant because all the ratios are positive here. So we have our 18.7, which lies in the first quadrant. So we have 18.7, which is our first answer. But there's actually another angle that will give us this ratio. Okay, and the calculator only gives you the acute angle. It only gives you an angle less than 90, but there's actually two answers. Okay, so how we find the second one is we have to find out what other quadrant sine is positive in, because this was positive. Okay, so if we look up at cast, sine is also positive in the second quadrant. So we actually have another angle. So this is our first angle, and then we actually have a second angle, which goes from here to here. And I'll show you to prove you that it's the same. Okay, so we have to find now the angle from here to this arm. But again, we can't find an obtuse angle the way it is. We have to use the angle that's in here, which is our beta. So if this is 18.7, just to let you guys know that this is also 18.7 in here. Okay, so from the x-axis to the negative x-axis is 180 degrees. If we subtract this 18.7, it will give us our principal angle from here to here. So the second angle we do 180 minus 18.7, and that will give us 161.3 degrees. So I'm gonna double check. 180 minus 18.7 gives us 161.3. It's kind of messy the way I wrote it. 161.3 degrees. So just to show you that it's true, if I plug sine of 18.7, I get 0.326, which is close enough to this because we rounded. So 0.326. Okay, so remember that angle. So if I plug sine of this angle, I get 0.3206. Okay, let's see if we plug this number, if we get the same thing. So sine 161.3, I get the exact same answer. So I also get 0.3206. Okay, so that just shows you that there is two answers. We have the acute angle and we have the obtuse one. Okay, so, or one that's larger than 90. So our two answers for this one. So 18.7, so 18.7 degrees and 161.3 degrees. Okay, now moving on to B. So we have cos negative 0.5804. So let's see what happens when we plug this into the calculator. So we get shift cos, because remember we're solving for A, so we do inverse. Cos inverse of negative 0.5804. Negative 0.05804. And we get the answer of 125 degrees. So in this case, A is 125 degrees. So 125 it goes in the second quadrant. So that means from here to here is 125 degrees. Okay. So again, we now have to find the other answer. Okay, so here cos was negative, and that shows that it's in this quadrant. And based on our CAS rule, cos is negative here. The sine is the only one that's positive. So now we have to find the other angle that relates to this one. So we have to find what other quadrant is cos negative in. So cos is positive in the fourth, so that means it's negative in the third. So our next angle, these are just rough. We're going to have an angle that goes from the initial all the way, from here all the way to this arm here. Okay, so we found the first one. Now we have to find the second one. So from here all the way to here. Okay, so this is how we find it. The 125 is from here to here. That means this angle, beta, will be 180 minus 25, 125. So that would give us, what is that, 45? 55. So this angle inside here is 55 degrees. Okay, so if this is 125 from here to here, then this angle here is 55. That means that this angle here is also 55 degrees. Okay, so again, I'm going to draw that again. So 125 degrees, that means this one is 50 degrees. Okay, but now we have to find the other quadrant where cos is negative, and that is in the third quadrant. So we want to find the angle from here to here. So 180 plus this angle here, which is the same as this one, always the same, 55 degrees. So from here all the way to here is 180 plus 55 gives us 235 degrees. Okay, and just to prove it, we can always check. So we get cos 125. So watch, cos 125 gives us negative 0.57, negative 0.5735. Okay, I know it's supposed to be 5/8, but that's close enough because we rounded. And now let's try cos of 235. Cos of 235 gives us, boom, the same answer. Okay, so we have the answers of, so A is both 125 degrees and 235 degrees. Okay, so when you're doing these, there's always two answers. Okay, last one here. Cotangent A is 1.8421. So we have a reciprocal function, so we have to switch this to a tan. So we put this over 1, we flip it, so that now it becomes tan 1 over 1.8421. Do the inverse, 1 over 1.821. So second function, tan brackets 1 divided by 1.8421 end bracket, and we get 28. We have to round it to one decimal, 28.5. So 28.5 degrees. Okay, we draw it out. 28.5 lies here. Okay, this was a positive number, so we have to find out where tan is also positive, because remember, all of them are positive here. Sine is positive here, tan, and cos, C-A-S-T. All right, so if tan is positive here, then it's also positive in this one for tan. So we're going to have another one here. So we're going from the initial arm all the way to this now new terminal arm. So if this is 28.5, this is also 28.5. So we go from here to here. So from the positive x-axis to the negative x-axis is 180 degrees. Add an extra 28.5. And we get 208.5 degrees. Okay, this is a very, very, very important lesson, so hopefully that makes sense. And if it doesn't, please ask. Okay, that is the questions. Homework here is page 299, 1, 2, 4, 6, ABC, and 8. Hope everybody is well, and we'll see you soon.